I have always wanted to create an anti-theft device using my software development skills, and I finally did it. If you have been struggling to catch your annoying sibling or roommate sneaking your snacks at night, or just want to ensure no one goes through your stuff without you knowing, you are in the right place. In this video, I will walk you through how I used an old phone and my coding expertise to build a full-fledged anti-theft device that will help you guard your belongings with ease. So, without further ado, let's dive in. First, let me give you a brief overview of the app. For this project, I'll be using Flutter to access the device's accelerometer and detect any movement. The core principle is simple. If there is movement, the app will alert the user via Vonage. Additionally, we will add an anti-tampering system so no one can bypass it by turning off or breaking the device. We will build the backend in TypeScript and leverage Vonage APIs to trigger a call and SMS alert to the user. Let's get started with the Flutter application first. After installing Flutter, let's set up the basic project. Firstly, we would need to install the VS Code extension for Flutter. Once installed, open the command palette. The command for Mac OS is Shift-Command-P. Type in Flutter. If the command is not visible for you, simply restart the VS Code once and it should work. We will select the Flutter new project and let's start off with the basic application. Since this will be a single page app with no components, we will just modify the boilerplate application to fit our needs. Let's find a suitable place for this and call this the movement app. And then we need to give the application a name. So let's call it the movement app. Alright, we have the basic app set up. I'm not going to be using the emulator here. Instead, I will be connecting my iOS device as we will be dealing with sensor data, which I couldn't find a way to mimic on the iOS emulator. Now open the iOS folder right here in Finder. So we will click Reveal in Finder. Let's go into the iOS folder and click on the runner XC workspace. Remember, do not click on this blue file. We need to be clicking on the white file. Double click. You will also need to ensure you have Xcode installed before this step. Opening this file will automatically launch Xcode. Now, once Xcode opens, I will skip over the steps to handle the signing certificate, etc. that is required to run this app on my physical device. For those who would be doing this for the first time, I have attached a YouTube link in the description below, which is a step-by-step guide on how you can run this app on your device. After finishing the signing steps, I am ready to run the app on my device. So to run the device, I will simply press this play icon. And Xcode will build the Flutter project on my device. And we can see the simple Flutter boilerplate app on the phone, which is the counter. So when I press this floating action button, we can see the counter keeps going up. Now let's go back to the code. And let me remove the commands, functions, and all the other parts that would not be useful. I have removed all the unnecessary commands and components from the app. First, let's install the packages that we would need. For that, we will go to pubsec.yaml and add the libraries here. And save. The VS Code automatically runs the pubget command to install the libraries. Here, we will be using Sensor Plus to allow us to capture sensor data and FL charts to plot those data onto the screen. Now, let's go to main.dart and import these libraries. We would put the import statements right at the top. Let's start getting the sensor data from our mobile. To get this, we will subscribe to the stream of the accelerometer. Accelerometer is the sensor that would help us get the movement data of the device. So before we jump into that, let me just change the title of this real quick. We will call this the movement app. Now let's subscribe to the stream of the accelerometer. So let's scroll down into the my homepage state component. Here we will declare an init state function. We would get the stream by using accelerometer event stream, and then we would listen to the events. For now, let's just print the events and see what we get. Let's go back to the Xcode and run this again. So this will rebuild the application. We forgot to build the iOS folder again because we installed new modules. So simply fire up the terminal and run flutter build iOS. This may take a couple of minutes. Application has now been built. So let's go back to Xcode. We will use the version on disk. Alright, let's build this and hope it works. Great, the build succeeded and the app is installing. So let's check the logs to see if you're getting the sensor data. As we can see, we are getting all the accelerometer events. So this is the X 0.23. We are getting the movement events on different axes, X, Y, and Z. Right now the device is stable, so there's not much variation. But if I move the device, did you see how the numbers rocketed from 0 to 6? So this is what happens when we move the device. The accelerometer can detect these movements and these values will change. And based on the change of these values, we will be able to detect movement and we would be able to alert the user. Now let's go back to the application and start making the interface for this. Let's go to the scaffold. Here we will need to change the main component that we are seeing, and we will need 3 buttons to switch between the axes, that is the X, Y, and Z. So to do that, I will just make quick changes here. This is a pretty simple component, so I'm not going to go very deep into it, but right now we have added 3 elevated button components into the app bar. The first component, right now there is no on press, so we will be adding some data here. The default color would be gray, and this will actually switch. So when the state is activated, we will use the color blue. We will be coding that out in some time. And the text for that is the X, Y, and the third button would have the Z axis. Let's just see how this looks in the UI. Let's go back, stop the application, and rebuild it. Yeah. So as expected, we can see all 3 axes, X, Y, and Z. Now let's start working on plotting the data that we get from the sensors and declare a variable called current axis type right above here. So we will be putting all our variables in this section. This variable will be of type axis type, which we will declare right now, which will be an enum. So axis type, and we'll have 3 axes, X, Y, and Z. So we will be defaulting this to the X axis. We see a bunch of squiggly lines, so this is because we haven't used this yet. So let's quickly go down and add a basic logic to switch color based on the active state and give it some functionality. So we can do that by modifying the return statement. Here we will just add this conditional statement. If the current axis type is equal to Z, then we will have blue, otherwise we will be returning gray. So let's do that for the other axes respectively. We have done that. So in case the current axis is X, then we will have blue, and same for each and every axis. Let's rebuild it. And as expected, you can see that X axis, because by default is selected, it is in blue color. Let's render the graph as well on the screen. So to do that, we need to understand how the FL library really works. We are going to plot the graph using the line. First, we will need to create an array of these events in a structured format that will help us render the graph. And let's declare a new variable called accelerometer events. So this will be a list of accelerometer event, which is the type here. So I will add this here as well. And we will push each and every event into the array. We will make 2 arrays. One will be for the format that the FL library needs it, and the other would be used to detect movements. So this will be our first one. This is to detect movements. And we have another list of FL spots. So FL spots is the data type that is required for the plotting of the line chart. and we will store this in an array called accelerometer graph data. And let's add the data as well. Let's use this into FL spot, which is initialized by the x-axis and the y-axis. So in the y-axis, we would want the value for the event. We are just going to add a new function for this. Alright, so let's understand what we did here. So I have created a simple switch case for better code readability. At one point of time, we can only display the value variation on either x, y or z. So based on that, we are going to return that specific value. So if the current selected value is x, then we want to return only this, because the graph is going to be a function of the y values, and on x we will actually have the current time. Because the graph on the y-axis has the variation on the sensor, but on the x-axis we have time. We will do this by declaring a variable called current time, and x-axis will have current time on it. Now we also need to increment this current time variable after every second. Let me explain what we are doing here. We will need two arrays for this project. Basically, in one we are just going to add the events and as and how we get them from the sensor. In the other array, which is going to be the accelerometer graph data, so we are going to use this to simply plot the graphs. After every single second we are going to add the value, and the current time will be incremented by 1. This function will continuously run every single second and update the graph as well. What we are doing here in this underscore get value for axis, because at any point of time, as we can see here, we will only see x, y or z axis. So it is important that we should get the axis value for only the selected axis. Based on the current axis type, we can return the value that we need. So if it is an x axis, which is the current axis type, we are only going to get the x values. If it is y, we would get y, and if it is z, we would get z respectively. Let's now work on plotting the graph. In the body and container, we want the color to be white. So let's go down here, and I'll just add some code and then I will walk you through it. So I have basically added some UI elements to our body. There is a container with the background color set as white. Then we have two children in a column, which is sort of dividing our entire screen in half. The first one is the expanded widget, where we will see the graphs, which has a basic padding. It is center aligned, and then we have the line chart. The line chart is basically from the FL chart library. Here we have set the minimum y-axis that will be visible to -5 and maximum y-axis that will be visible to 10, because we know in general the range of the graph will be from -5 to 10, but it may fluctuate beyond these limits as well. But the objective is to get alerts rather than just look at the graph, so we are just going to take arbitrary values right now. Then we have the line bar chart. This is where a graph will be actually plotted. So the spots are basically nothing, just the FL spots that we configured above. So as a time passes, we will start adding more and more data into this list, the accelerometer graph data. In case it is not empty, then we will use the direct list. But in case it is empty, we would just have a default 0 graph plot going on. This is some configuration for colors and colors for the graph that I've added. This is completely optional. So this is about it. Again, most of these are standard configuration for the graph. Let's go back to Xcode and run this again. So we can see that the graph is here, and it is right now not plotting anything. Now we need to see why that is happening. We can see our basic UI is up, and now we will need to start plotting this graph as and when we get the data. So let's check that out. So let's go back to the code, and here in our accelerometer event stream, the problem is that we are not using set state, which is important for the UI to update. So let's just add that quickly, and we will just copy this code and paste it in here and save. Let's restart this code. Great. Now we can see that there is a small line which is moving with the values. Right now I'm just moving the device along the x-axis, and we can see these spikes in movement. this actually, the UI is not that great right now, because when I move it a bit too much, we can see that there are peaks going outside the graph. At the moment, we will not be fixing this, and we'll be trying to live with this small issue. But if you do know how to fix this, do let me know in the comments. Let's go back to our application and add the functionality to switch these graphs as and when required. To add the ability to switch the graphs on the axes, all we need to do is update this onPressed code to allow us to reset the graph and change the current axis. So I'll create a function to clear the current graph values. So that is very simple. We will just go here and create a new function called reset graph. And we will not forget to call the set state this time. And we will simply clear the graph data. So the moment we reset this, we will be starting afresh. Meanwhile, we will also need to change the axis. Let's just go to each on press. So for this is the x axis. Let's change the current axis to x. And then reset the graph. Let's copy and paste this for the other two buttons as well. And change the axis type. So for Y we will use Y, and for Z we will use Z. Let's hit save and start this again. Awesome, so we have started plotting it a bit. Let's try this out again. Yes, we get the graphs as per the movement. Let's switch the axis. Here we see that the axis has been changed and it is working as expected. Let's go to Z. So Z is actually the axis where we are having the gravity pull on the device. So this will be closer to 9.8 and 10. This seems workable with. Now we will add the functionality to show the movement values here in real time, as well as detect the movements next. Now let's quickly add the lower segment as well, which will simply show the current values. To do that, go back to the code and open the lower expanded component that we had made here. I'm going to quickly modify this for each axis, X, Y, and Z. Here you can see that I added three simple text components in which I am logging the X axis, Y axis, and Z axis. Let's go above and also update these values as and when we get the event. So for that, we will go above. We will declare the values here, which will be of type double. And we will also set these values in the init state function. Great. So now as and when we get the events from the accelerometer, we will start updating these variables, which will be displayed in the text widget. Let's go back and rebuild the application. We have an error here. It says not a constant expression, line 209. So let's check that out. Okay, so we'll need to remove the const declaration that we have here in the expanded widget. So let's remove this and save. Let's rebuild this again. We see that the values are changing in real time. As and when I move the device, the value will also erratically change. So let me move the device. Can you see the abrupt variations on the values? So this is how we will be able to detect movement. Whenever we detect abrupt variation in the values, that is when the movement has been triggered. So let's go back and start working on this logic. Let me explain all the possible edge cases that may occur in such an application. First, what happens when the phone's default surface has an incline? In this case, we need to set a baseline. In other words, we need to calibrate the sensors of the phone to detect initial position. Secondly, as we can see with these numbers, even when the device is kept on a very stable platform, the readings are oscillating continuously and are not exactly constant. This is the second problem. So let's start detecting movement with these cases in mind. For the first 100 readings since the app has started, Instead of simply starting to detect movement, we need the app to understand the current position. And only if deviation from the current position is detected, we should trigger a movement detected notification. So let's have a look at the current screen. As we can see, we have roughly 9.8 reading on the z-axis. This accounts for the gravity. We obviously don't want to alert the user if gravity is acting on the object, because that would make a pretty useless alarm. Similarly, we also see that the other readings are not exactly at zero, implying there is some movement that the sensors are detecting. So, our step one would be to find the average of the first 100 readings and then basically account for these in our processes. So, let's create a function which will take a list of accelerometer events and then calculate the average. So, we will call this calculate threshold, which will basically take in a list of values and then calculate the sum of the entire array, and hence calculate the average here with certain margin, because we are adding this margin because we can see that there is some variation even when there is no movement. This will allow us to account for a margin of error. Next, we will need to call this for each and every axis. So here I'm going to add this piece of code. Let me also declare these variables and then walk you through it. So here we are basically storing the thresholds of x, y, and z. We are basically letting the application know that movement of magnitude till this variable is allowed. Moving below, we will calculate these thresholds. So we are adding the absolute values of the event because we are seeing that certain values are in negative. Why we get these values in negative, I will be explaining right after I explain this code. We convert the list of events and send them to this function, which will give us the threshold for x, y, and z axis. We log the values and also give the message to a user saying recalibration has been successful. Also, we are using something called as a movement detected boolean to understand whenever a movement is detected. We will be using this later on in the code. Let's understand why we are using the absolute value, which is basically the positive value, with a simple example. On an axis, when a movement is detected in a particular direction, we will annotate that position by positive. But when the movement is detected in the opposite direction, we call the movement as negative. In this application, however, don't really care about the direction of the movement. We care about the magnitude of movement. Whether it's left, right, up, down, we won't be worried about the direction. We will be worried on how much the device has been moved. So that is why we are using absolute values everywhere to ensure that we are only comparing the magnitude and not the direction. Let's go back and see the threshold calibration now. Let's rebuild this. So what will happen after 100 events is we would see a calibration event being fired. So let's check that out. Yeah, so we got this message successfully and the threshold's been set to 0.17, 0.1, 9.8 for the x, y, and z axis respectively. Now we will use these values to detect movement. Let's go back to the code and create a function called check movement, which will take in a accelerometer event. Let's collapse this and add this function here. So here what we are doing is basically, if the length of the accelerometer events is 100, we need a large enough data set to calculate the average of the values, and no movement is detected. If generally when a movement is detected, there'll be violations on all axes, and we don't want 3 separate notifications going to the user. So hence we will only alert the user even when we have a movement detected in a single axis. Here we will compare the current value of the event of the x-axis, and we will compare it to its respective threshold. We will do that for all axes. Whenever a movement is detected, we will mark the variable as true, we will add a log, and we will trigger a show movement message function. I'll add the function as well now. So we will simply trigger a message that will say that movement has been detected by so and so axis, and after 5 seconds we will automatically reset it, so allowing detection for other movements. Here I have added a to-do placeholder which will basically make an API call to trigger call SMS functions, which we will add in the next section of the video. After this function has been declared, let's call this in the setState function. Let's go down, collapse this and call it right here, and we will pass in the accelerometer event and save. Let's run the application now. Once the application has been built, we will wait for 100 events to start the movement detection. So the calibration has been started. Great. We have our recalibration successful. Now when I move the device even slightly, I'm going to push the table a bit on which the device is on, we will see a movement has been detected. This is how powerful the sensors are. It is detecting a movement in all axes. Now let's wait for a few seconds, and I'm going to slightly drop a book on my table. And we have another movement detected. Try this out yourself. After some time, this is pretty fun. This could make a very interesting game maybe. Now that was a lot, but we have a lot more to go. So let's begin coding the backend now. Alright, now let's start coding out the backend logic for our application. I've decided to develop the backend in TypeScript. Although I have dabbled in TS before, it's been a while. I will skip over the parts I get stuck, so you don't have to painstakingly watch me navigate my way through the basics. I have opened a new folder called server in VS Code. So let's start by running npm init-y. Good. We have initialized our package.json. Let's generate the TS config by running npx tsc-init. There is some configuration that I prefer, so let me just show you the final file. I have removed the commented configuration which wasn't relevant to this project. This is pretty standard. I'll just point out that our root directory is going to be src and the build would be in a folder called dist. Let's quickly make the folders that we would surely need. src, let's place our index.ts and app.ts here. And let's create the other folders: routes, helpers, controllers, and db. This would be good enough for now. We will start by setting up the server first. Let's install the packages we would surely need: express, cores, .env, and their types of course. Done. Let's also set up our scripts. I always like to have 3 scripts in my project: build, start, and dev. For build, I would use rimraf dist and run npx tsc. I would explain this in a minute. Start should build the project and then serve it. So let's run npm run build and node dist /index.js. For dev, I would definitely recommend nodemon, which makes it a lot quicker while building applications. Nodemon src/index.ts. Coming back to the build script, the rimraf command will delete the existing build, which is the dist folder, and npx tsc will generate a new build from the source files. You would need to ensure you have rimraf installed to use this. Like always, if you face any problems, just comment below. Alright, let's head over to app.ts file and set up our project. Let's quickly import the libraries we would need. That's express, cores, and body parser. Create and configure the express instance here. And let's start with the root route. App.get, we would use the request type from Express, and this would be response. This endpoint will simply return movement API is up and running with a 200 response code. Great, let's export the app instance now. Head over to the index.ts and import it here. Let's put app.listen 8080 with the callback function, which would just log server is up. I'd prefer using the env for the port, so let's set the port as process.env.port. Create a .env file, port is equal to 8080, and simply use this variable here. Let's import the .env and call the config function. I also prefer using emojis in my logging, so let me just search for a rocket emoji real quick. Copy and paste. I will run this now by running npm run dev. Yes, the server has started, and let's see if the application is serving. Indeed it is. So our basic TypeScript server is up and running. Now it's time to configure the core functionality. Now we would require 4 routes in this application. First, we will begin with the post route, which will be referred by the alive path. This would be pinged by the client app every 30 seconds to indicate that the mobile app is indeed up and running. If the device goes offline, maybe because the phone was shut down or somebody tried to tamper with the device, then we would want the user to be alerted. Let's create an index.ts in the routes folder and start by importing Express. Initialize the router and create post/alive route, and let's export the router. And now let's create an index.ts in the controllers as well. We will not be complicating the application with a very savvy directory structure for this video. I'll create an alive function. Let's start with a basic try-catch block and log the error. And let's put this as the any type. And in this case, we would want to return res. Okay, wait, let's just get that out of the way. Yeah, there we go. And we would want to return status 500, a message internal server error. And let's export the function and return res status 200 if the request is a success. Updated alive timestamp. And let's import this function in the route. Let's import the controller. Yeah. Let's also import the router in our app.ts. So let's have routes imported separately. Import routes from routes, and we will set this in the API path. So we'll have app.use/API/routes. Let's run the server and see if everything is all well. Good, the server is running. And let's fire up Postman to test this endpoint out. I'll be creating a collection called Movement API. Create a new request in this collection. Let's call this a live request. This is a post request, so we will change this and put in the endpoint. Don't forget that we are on the /API/alive. Let's hit send. This works as expected. We're getting a status code 200 and the message is successfully updated alive timestamp. Now let's add some validation in our controller. This is because we don't want anyone to call this endpoint and update the alive timestamp. So for this, we would need to generate a unique random token. Go to the browser, search for random string generator. Open the first link you see, and we will now generate a random string by clicking this button. Just copy any random string that you're okay with. Now this specific token will be used to validate all our requests and identify the unique device. Let's go to the env and store this in the keep alive token variable. We will be using this in some time. I think it's time to set up our database. I'll be using MongoDB for this. Create a mongoose.ts file to initialize our connection with our database. Let's quickly install Mongoose as well and the type. Let's clear the terminal. Now we will import Mongoose and we will set the config here. So it is important to set the strict query parameter to true, otherwise we will end up getting some warning. I forgot from here. Now let's connect to mongoose.connect. We will use an env variable here, process.env.mongodb URI, and I will set this in the env as well. Go to the .env file and set this variable up on MongoDB URI. Let me just make sure it's the same. Localhost. So it's running on port 27017 / and I will connect to the database which will be movement. There are many guides available on how you can install and run MongoDB on your computer. You can do this by going to Google and searching for how to set up MongoDB instance on your machine. Say mine is Mac, so there was brew for that. Let's go back here. And we see that we are getting these red squiggly lines. It's because there's type checking here. So if process.env.mongodb URI is basically not present, then we would want to throw an error stating MongoDB URI is not provided. And with that, the red squiggly lines have gone. Let's log success message on connection. So we will do mongoose.connection.on. On the open event, we would want to simply log a success message, console.log connection to database successful. Since you know I like to use emojis, so I'll just quickly get this rocket emoji back here and we are good. Okay, so we should also be logging the error in connection. So mongoose.connection.on error. We will get the error object, set this to type error, then console.log an error occurred while connecting to DB, and we will also log the message. Save, and let's import this file to index.ts. After the envs are fetched, we'll do import /mongoose. Okay, let's run this application now. npm run dev. Great, and we see the server is up as well as connection to the database was successful. So if you have faced any issue with this step, it's very likely that the Mongo server is not running on your system. So you can Google on how to set up Mongo server and you should be good to go. Let's close the server and clear the terminal now. We have made great progress. Now, I want to create the alive model to store data related to the device. Create this in the models folder right over here. Let's define this Mongo schema. First, let me import Mongoose. Const alive is equal to new Mongoose schema, and let's export this. Alive model is equal to mongoose dot model alive export default alive model. Alright, so in this we would need practically 3 fields. First one is going to be the alive token, which would be of type string, and it would be required. So each client will have a unique alive token. Then we will have last pinged, which will be of type date, and it would be required as well. Let me use camel case here. Okay. And we will have the final field, which is activated, which will be of type boolean, and we will have a default value here set to false, because when we create the device we do not want it to be activated instantly, and this would be required as well. Alright, so the last ping is a timestamp which will allow us to identify when was the last time the device pinged the server. And activated is a very important field, as only when this is set to true, the alerts for the device would work. Otherwise, you would end up having an endless amount of alerts from the system. Let's go back to the controller. So in this, we would be sending the alive token in the authorization key, and we will validate it using a simple if statement. So let's add validation here and destructure the authorization token. We'll call this as the alive token is equal to request header. And here, if the alive token is not equal to process.env.keep what was that again? 1 minute. Yeah, keep alive token, or no alive token is provided, then we would log this as an error, faulty auth token provided. And I always like logging why an error was logged, so I will also log the alive token so we can easily debug this if it's a problem in the code. And return, we will actually give out a 500 error, because we do not want any information about the system to be given to the attacker, and let the attacker assume that it was an error in the code. Perfect. So in this scenario, we are only assuming we have one device, but in reality, if you want, you could scale this up to multiple different devices. So you would need to change the way authentication is done, maybe use JWT, or you can set up an API key generation system, which will allow you to uniquely identify which device is hitting this route. But for the scope of this project, we are assuming that only one device is using the system. Okay, so let's run the server and check out the validation. npm run dev, open postman, and let's send the same request again. See, we have an internal server error, and there was no authentication token provided. So let's change this up. Let's provide the authentication system this time. I'll go to headers and type in authorization and paste it here. Save the request, and now we would send this. Great. We have successfully tested the validation of the alive token. In the event of an invalid token, we will simply reject the request and add a log to the server. And in the event of a successful request, we will proceed as intended. Now we can simply import the alive model here. So let's update the last ping field. So we'll have this will be an asynchronous call to a live model. My editor will auto import the model as well. We will use find one and update because the alive token is going to be unique, and here we will have a live token as our query. So what another thing you need to note is that because tokens are very sensitive, we should ideally be hashing them, and we should never store the token in plain text in our database. But again, for the scope of this project, we will skip the hashing to make this more simpler, and we will set the last pinged field to right now. Also, we will allow new true as well as upsert to true. Why we are using upsert is basically to allow us to create a new document in case this document does not exist. Because we have already validated it, we know that the document should exist, so we will just simply upsert it. Now let's try this out again. Go back to Postman and hit send. Okay, so we did not get any error. So I'll be using MongoDB Compass, which is basically a GUI for Mongo databases. Let me open that up 1 minute, and I'll just modify this connection string to connect with our database /movement. Just match this with the env that we provided and connect. Like always, ask me later. So as you can see, I have different databases that I've worked with in the past, but what we are interested is in the movement database right here. So let's open the alive collection, and here we can see that the last pinged was set to the timestamp that the route was executed at, and right now it is not activated. The alive token set to what we provided. If I hit this route again, we would also, and refresh this, just note the timestamp right now, we would see that the timestamp also updated itself. So we have successfully implemented our alive route. Next, we need to write a cron function which runs every minute, and in case it finds an activated device to be offline, that is, it hasn't been pinged for the past 1 minute, then we should be alerting the user. So simply head back to the code. I'll just collapse the directories, and we will create a new file called cron.ts in the source folder. We would be using a package named nodecron for this, so install it using npm inodecron. And don't forget the types. Great, let's clear the terminal and import nodecron and create a function called find offline connections and add the basic try catch within the function with error logging. Define this as an any type, and let's run this function on start, and as well as schedule this function to run every minute. So how we do that is simply by running cron.schedule, put up 5 stars. This is how you set a cron schedule, and this takes in a callback function. This is where we'll call our function we created above, and we would start this. Alright, so what this basically does is it tells the cron function to run every minute and execute this specific function. This call simply starts the cron scheduling. Let's import this into index.ts and then run this. Before we do that, let's just place a log so that we know that the cron function is running for offline devices. Okay, let's run this. So this first log has come up because we have run this function on startup. We want the function to run the moment the program starts, and from now on you can see every single minute there will be a log that we keep getting. So I'm just going to time lapse this for you. so you can quickly see how it looks after a few minutes. As you can see, the cron job runs every single minute and executes this function. Now this will help us to constantly check for devices that have gone online. Just to reiterate, how this check would work is that we would query the database for all the devices that are active but the last ping was more than a minute back. In this event, the device has gone offline because this client is supposed to send a live message every 30 seconds. And once we find that a device has been deactivated unintentionally, we would immediately notify the user using the Vonage APIs to send an SMS. Now, let's add the query that would let us know when a device goes offline. So, for that, we need to generate a timestamp that is exactly 1 minute old. Now let's use this timestamp to query the alive model. Let's import it. We also need to ensure that the device is active in this case. So find using activated true. If the results.length is greater than 0, we will take that to mean that devices have gone offline. As in this scenario, we only have one device, we will just destructure the 0 element. We will add a to-do here, where we will call the Vonage endpoint to trigger an SMS later. And we should also deactivate the device, otherwise we would get the same alert every single minute when the cron job runs. I would add another console log to know when the function is finished running. So in the first run, we can see that it didn't get any devices that have gone offline. This is because that we haven't sent any alive signal for an activated device. Let's go back and activate the device. Yeah, so we see this log because the device is activated. However, the last ping has not been updated yet, and we can see the activated has been set to false. Let's make two routes quickly that would allow us to get and update the activated field to avoid updating constantly in the database. So I have quickly created these two routes. One is a get route and one is a put route. In the get route, we have slash device, which will get the current activation state of the device. It is a very simple validation that we have used before. We find the activated field using the alive token and we return that. Let's test this route out. So in Postman, let's open get route. Here, if you can see, it's the slash API slash device. When we send this request, in response, we get the ID and the current activated state. Now, to update the state, we have created the put route in the slash device path itself, which will update the activated state based on the alive token. So we perform the same validations here. One extra step we have here is we are taking the activated field from the body itself and having the relevant validations. Find using the alive token and update the last ping because this is the last time we received any request from the device itself, and set the activated state to provide to the one that was provided. So this will allow us to activate as well as deactivate a device. Let's test this out. This is a put request on slash API slash device with the body set to activated true. Let's send this and we will see that the device has successfully been activated. If I quickly fetch the new status, we will see it's true. And if we allow the cron job to continue running in a minute, we would see that the device would also be taken offline because the last pinged route is not being hit right now. So in the first run, we would see that the device is still activated because we had updated the last ping right here. And in the next 1 minute, because we are not going to be hitting the alive route, we would see that the device has been taken offline. So as expected, the device has been taken offline and it would also be deactivated, which we can see by fetching it again. The activated state has become false. Now, before we go any further, I'd also like to take a minute to mention the Morgan middleware. If you have noticed, every time I make a request, be it this get request or a put request, we get 0 logs. It will be very useful to have logging whenever we have a request to understand better the request coming to the server. We can do this by using a package called Morgan. Let me show you how you can set this up. Install Morgan by running npm i morgan. Now import it into app.ts and use it down here, app.use, calling the Morgan function, and add this string as a parameter. While you can refer to the Morgan documentation for more information, but to break this down, it simply uses the date, the method, URL, status, content length, and the response time, and it would log this for every single API request that is made to the server. Don't forget to import the types for this, so I'll do that right now. Now let's just run this. Now if you would see that if whenever I make a request, it will also log certain data for that request as well. So if I make a get request, we would see a log exactly stating what time the request was made at, the status code, the type of request, path, as well as the status code that was returned. Similarly, for a put route, it would change that to a put method, and so on. Let's clear this now. Now, this certainly can be very useful in debugging and monitoring how the application is being used. So this is something that I generally include in all my projects. Now let's get back to the application. Next, we will be integrating Vonage APIs and use it down here, app.use, calling the Morgan function, and add this string as a parameter. While you can refer to the Morgan documentation for more information, but to break this down, it simply uses the date, the method, URL, status, content length, and the response time, and it would log this for every single API request that is made to the server. Don't forget to import the types for this, so I'll do that right now. Now let's just run this. Now if you would see that if whenever I make a request, it will also log certain data for that request as well. So if I make a get request, we would see a log exactly stating what time the request was made at, the status code, the type of request, path, as well as the status code that was returned. Similarly, for a put route, it would change that to a put method, and so on. Let's clear this now. Now, this certainly can be very useful in debugging and monitoring how the application is being used. So this is something that I generally include in all my projects. Now let's get back to the application. Next, we will be integrating Vonage APIs. Open dashboard.nextmode.com and create an account if you don't already have one. You may have some free credits given by Vonage themselves to try the application out. I had to purchase some credits because my account was pretty old. Once you have been set up, go to numbers right here and click on buy numbers. Select the country as USA, and since we will be using SMS and voice for the alerts, so select both. Click search, and you should have all available mobile numbers here. You can purchase any number that you'd like. Once purchased, head over to your numbers section right here. Now we will need to create a Vonage application to get the necessary keys. Click on applications and create a new application. We will give it a name. I'll call it movement. Generate the public and private key. Save this in the root directory of your server folder. Don't forget to turn on voice and message capabilities. We can ignore these URLs for now and just set default values, like I'll be setting example.com, which is in the placeholder, and generate the new application. We will also need to link the number we just purchased to our new application. So just click this link. My number is already associated with an older application, so I am also unlinking it. Good. Our number has been linked. Now let's quickly copy the credentials that we would need in our code so we can use the Vonage APIs. So we would require the following envs. We would need the application ID, the API key, the API secret, the Vonage from number, and to number. Let's quickly fill this out. Your application ID would be present right here. Let me just paste that. Your Vonage API key is present right here on the application. It is also present on the dashboard. The Vonage secret would be present only in the dashboard. So let's go there. 1 second. Go to the API settings and you would see the API secret here. For the Vonage from number, we would go back to our numbers and copy the number that we just bought. Just remember, now for this number we will have to remove any spaces, brackets and the country code. So we have the country code without the plus symbol and the rest of the number. Similarly, for your number, you can go ahead and add your number. Just remember to put it in the same format. No plus, no brackets and no spaces. Once you have filled up the entire envs, we would now start initializing our Vonage helper. So open a new file called vonage.helper.ts. Let's install the server SDK. So that would be npm I at vonage/server-sdk. To initialize our Vonage instance, we will first need to create a new auth object. So just import the following packages, and first we will configure the auth object. Alright, so we will be giving our API key, which will be taken from the envs. The API secret and application ID would be taken from the envs as well. The private key is basically the path of the private key, so I'll just rename it to private dot key. Just make sure this file name is the same as the one in the helper, and using this auth object we will initialize our Vonage instance and export it. So now we can use Vonage from any part of our application. Now let's start integrating the Vonage functions into our code. First, we will add the SMS functionality. Open the cron.ts file and let's go to this to-do placeholder that we had set. The Vonage SDK makes it very easy to send an SMS. So just see what we need to do. We will import the Vonage instance from the helper. VS Code will auto import it. We will do .sms.send. Seems pretty obvious, doesn't it? We will need 3 parameters here. We'll have a to, from and text. We see that we get these red squiggly lines from TypeScript because there's a possibility of these envs not being present. So we will add some validation before we reach this block. That can be simply done by adding a simple if check and save. And those error messages are gone. I'll remove this to do and we are good. So let's try this out. I'm going to run npm run dev and open Postman to activate the device. We are using the update route that we built, and we can see that the service was actually already activated and it was offline. I have received a message from Vonage itself. Let me put that up on the screen. So that's it. So this is how you can integrate Vonage to send you SMS alerts. Even after the device has alerted you once, it will deactivate automatically so that we won't have multiple SMSs being sent for the same device. Now we will develop the final route for the backend application. That will be the movement detection route. Just to remind you, this route will be triggered whenever a movement is detected, and then a phone call should be sent to our to number to alert the user. So let's set this route up. Go back to the index.ts in the routes folder and add a new route. We don't have a function for this, so we will first create the function before calling it. Open the index.ts file in the controllers. Let me just collapse this. And we will just start with a very basic try catch function and then fill that up. Okay, so here I have not added much. We have the basic validation that we have in all the other routes and the error handling that we have built for every single function before. Now let's populate this function. Firstly, we will need to fetch the device using the alive token that we have obtained. That will be a simple find one in Mongoose. Here what I'm doing is simply querying the Mongoose collection with the alive token, and I'm also searching for only activated devices because we do not want to fetch the device not activated. Then we will scroll down and handle the error that is possible here. In case we do not find a device, then we will let the client know that the device is offline. Now let's simply use the Vonage helper to create our outbound call. Alright, so we have added the basic validation that we added in the cron.ts as well to handle the case in which we don't have the relevant envs present. Then we use the Vonage voice create outbound call function to create an outbound call. So how Vonage works is basically using something called as an NCCO objects. which is nothing but a Nexmo call control object, which lets Vonage know how exactly it is supposed to process the call. So if we see, the first object is a 2 key, which lets the Vonage know that this it's a normal phone call made to the 2 number from our Vonage phone number. As we can have multiple Vonage phone numbers, it is important for us to specify which one. And NCCO is after the connection is done, after the user picks up the call, what are we going to do? So in this, I'm just using the Vonage text to speech. I'm letting it say alert alert and let the user know that a movement has been detected for their device. So I'm just logging the response object as well. Like in the cron function, we will be deactivating the device again, because movement can be made multiple times during that one incident. So we want to deactivate the device instantly and then return the message to the client. Now, so let's go back to the routes and add the function call and hit save. Done. Now let's try this code out. So I'm going to head over back to Postman and I'm going to activate this device. Now that the device is in the active state, I will duplicate this request and let's make the changes here. Let's verify this. So it's a post route and it's movement detected. So let's copy that. We can see Morgan is working well. Save and send. Alright, so this is a good thing. We see our Vonage call has been initiated, and soon, generally this takes about 2 seconds or something, and we see a call. So that's it. That's how simple making the backend was, and that is how easy it is to build applications with Vonage. Now that we are done building the backend, let's go back to the mobile application and integrate these routes. We need to integrate the two routes here. One is the keep alive route, and the other is to trigger the voice call whenever movement has been detected. In the init state function, we will use the same timer function we used to update the graph to ping the backend every 30 seconds. We will use the HTTP method on the Dart async library. Now, we also need to enter our endpoint and our authorization token, that will be the keep alive token, to make this post request. For that, we need to host the code. Or we can use ngrok. For this tutorial, I'm going to use ngrok. For those who are not familiar with what ngrok does, it simply opens up a dedicated port on your local machine through an ngrok URL. You can easily install it by following the documentation on their website. The link is in the description. To activate it, I will run ngrok http 8080. We will need to also ensure the backend is already running on the same port. This will give us the unique temporary URL pointing to this port on our machine. Let's copy this and paste it into our HTTP call along with our unique token and add the endpoint path. Our endpoint path is /alive. So I think it's under the API route if I'm not wrong. So it's /API/. So let's save this and let's build it again to see if it's working. Failed because we haven't used async here and we are still using await. So let's fix that quickly. Save. And then let's just run this again. A function expression can't have a name. Okay. This is on line 152. In Dart, we will be adding the async right here. Save. And let's build this. Okay, so we haven't imported HTTP. Let's import HTTP as well. Let's add this again. Delete the build folder here because we'll need to build this again. To build iOS. The app has been built. Let's go back. So the app has started. So let's wait for every 30 seconds. We should see get requests coming from this device. Oh, we see that we are getting a large amount of requests from the mobile app. Let's go ahead and debug this. We should be only getting one request every 30 seconds. Doing some research, I realized that we are doing two things wrong. Firstly, we need to move this outside the event listener. There. So what was happening as the events were flowing, it was just creating multiple. So if you have 100 events, it creates 100 requests parallelly being fired after 30 seconds interval. That is why we ended up flooding our server. By that logic, this shouldn't make much sense. We shouldn't need a periodic function here. So let's remove this timer, as it doesn't seem to be adding much value, and save. Let's run this code again and see what happens. The device has started the calibration, so I will move on to our server and see what's happening. We should be expecting a request shortly, and there we have a request. So we will start seeing after every 30 seconds some request is being made. So we know that the integration for the first route is successful. Let's add the code to trigger the movement request. So the same way we have added this code. Let me collapse this. Basically, no matter what, whenever a movement is triggered, we will be displaying a show movement message. So let's go into this function. And we will make the API call right where we had placed the to-do. Let me just simply paste in the request that we're going to make. Done. We have made the API call request, and we will just add this the async keyword here. Great. So honestly, we are actually done with it. Let me open Postman, and now let's get the activated state of the device. We see the activation status is currently false. Let's rebuild the device, and now we will have a proper end-to-end test for this application. So right now we are waiting for recalibration. Once the system has recalibrated, we will try to we will activate the device, and then we will do some movement to see how it looks. Keep your eye on the screen. Great. So recalibration has been done. Right now the phone is stable. I'm going to gently go back to Postman, and I am going to activate the device, because if you remember, we are not going to trigger any call or alerts unless and until the device is activated. So activation updated. Now we are going to trigger the movement, and there we have the alert immediately coming to us. So let's I'll just put this on speaker and see what we can get. This number, if you can see, is also the same number we have bought.
Alert. Please note has been detected for your device.
So this is exactly how the system will work end to end. The device is now deactivated, so all these other movements that I'm doing, they will not be reported. In fact, we will send a failure request. We are getting all the requests here, but we are getting a 404 response because we cannot find the device in the activated state. So here you have it. This is how I basically built an anti-theft system, just simply using a backup device and some coding knowledge. So obviously the application is pretty raw right now. It has a lot of straightforward code and no very complicated folder structures to keep it very simple. And do let me know if you have suggestions. The link for the code repository will be in the description below. Do like and share the video, and do let me know what you thought about it.